Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2020, problem number 18. The problem says that let M be an n cross n non-zero skew symmetric matrix, then the matrix I minus M into I plus M whole inverse is always singular, symmetric, orthogonal, or idempotent. So there are four options. We have to we have to choose the correct one. About the behavior of this matrix, this I minus M into I plus M whole inverse, right? So given that M is skew symmetric matrix, that means M transpose is actually minus M, right? This is the property of skew symmetric. So let X be the given matrix I minus M into I plus M whole inverse, right? And let P be this matrix I minus M. This In just means the identity matrix of order n cross n, right? So let this be P, this one, I minus M. So P transpose is nothing but I minus M whole transpose, which is I transpose minus M transpose. Now since M transpose is minus M, therefore it is nothing but I plus M, right? But I plus M is this one, right? This one. Therefore X is actually nothing but P into P transpose inverse, right? X can be written as in the form of P as P into P transpose inverse of the P transpose, right? So now eigenvalues of a skew symmetric matrix is either 0 or purely imaginary. Okay, we know that this is a property of skew symmetric matrix. Eigenvalues of a skew symmetric matrix is either 0 or purely imaginary. Now therefore if lambda is an eigenvalue of M, then lambda is equals to IB, where B is a real number. I is nothing but the iota here, root over of minus 1. So lambda is actually I into B, where B is a real number, right? Therefore the eigenvalues of I plus or minus M are nothing but 1 plus or minus lambda, right? We know that. So obviously, since lambda is of the form IB, lambda is of the form IB, therefore 1 plus or minus lambda can never be equal to 0, right? Therefore it is non-zero. Therefore the eigenvalue of I plus or minus M is not 0, right? And since the determinant of a matrix is nothing but the product of its eigenvalues, this reason I have given. Therefore the determinant of this matrix I plus or minus M is non-zero, right? Therefore P being I plus M is actually non-singular, right? Because the determinant is non-zero. Now why do we need this? See, X is this one, right? P into P transpose inverse. Therefore determinant of X is actually date of P into date of P transpose inverse. So this is nothing but date of P into 1 by date of P transpose. Now this thing and this thing, now obviously P, as I said, P is non-singular, that means determinant of P is non-zero, right? So this reciprocal is actually defined, right? So this is det P by det P, because determinant of a transpose is the same as the original matrix. So this is det P by det P, ultimately it's 1, which is not 0. Therefore X is non-singular. Therefore first option is not true. Now for the second option, let's try to find the transpose of X. So X transpose is actually again I minus M into I plus M inverse whole transpose, right? So transpose actually does what? It distributes, but it actually reverses the terms in the product. So this is I plus M whole inverse whole transpose into I minus M whole transpose, right? Because the terms get in the reverse order. Initially it was I minus M into I plus M whole inverse. Now it is I plus M whole inverse whole transpose into I minus M whole transpose. This is nothing but the transpose and inverse interchange here. Transpose and inverse. So this is I plus M whole inverse into I minus M transpose, just distributing the transpose. So this is I plus M transpose whole inverse into I minus M transpose. Now M transpose is minus M, remember, because M is skew symmetric. So this is I minus M whole inverse into I plus M. Now this is X transpose, right? Now therefore X transpose X is actually, now clearly X transpose is not equal to X. Therefore X is not symmetric, clearly, right? Now X transpose X is actually, just writing the terms, this is I minus M whole inverse into I plus M, and writing here X I minus M into I plus M whole inverse, right? This is just X transpose X. Now I plus M into I minus M is actually what? This is nothing but I minus M square. Again I minus M into I plus M is again I minus M square. That means these two terms are actually the same, right? That means I minus M and I plus M commute. That means that product can be written in either order. It doesn't matter. So X transpose X is actually this one, right? As we just said now. So this thing can be reversed. This particular term, this second term and third term can be reversed in the order. So this is basically because the product is same. This particular product is same regardless of the order. So this can be interchanged. So this is again I minus m into I plus m. The first and the fourth terms are the same, and the second and third terms is interchange. So this is I minus m into I plus m now, and this part is obviously I, because this I minus m inverse into I, and again this part, this third and fourth term is again I. Therefore, ultimately it's I, right? So X transpose X is I, identity matrix. Therefore, X is orthogonal. So our answer is that X is an orthogonal matrix. The given matrix is orthogonal. So here we have the solution to this problem. It's a very easy problem actually. We just needed to know the properties of various matrices, and that's it, right? So it was very easy problem. And obviously lastly, the thing that was quite to trick was that the main trick was that here for X transpose X, here this terms, this I plus m and I minus m actually commute. So that was the only thing that was needed, the trick for this sum. So anyway, so now you have it, the solution to this problem. So do like, share and subscribe to the channel for more exciting problems. See you till next time.